Good morning. We are going to start a new topic and it is called differentiation. Now, differentiation is a part of calculus and we'll be working through this for the next few weeks. Now, one of the things that's really important is you are secure with surds and indices. So if you're not totally okay with those two topics from National 5, I would advise that you go into the National 5 section on my website and you go through the lessons, because it will make this topic so much easier. Okay, I'm going to read through this. So differentiation. Now we're going to start off with, you've seen this thing. So we're going to say, suppose we have a function, and that function is the y coordinate is equal to f of x. Now you've got formulas that are written as fx because it's easy then to tell you a value of x to substitute into a formula, but both those things mean exactly the same. So if we have a function fx, then a special function can be derived from fx. Now, what does it mean when you derive something? It means that you use that thing and you change it into something else. Okay, so this special function can be derived from fx. Now, it's given the notation f dash x. That's how we read it, as f dash x. And f dash x has got several special names. When you're asked to work out this thing called f dash x, then it could be given any one of these names. So you've got to remember them. The first one is f dash x is called the derived function. They could say f dash x, find the derivative of function f. There's other ways that you could be asked it. It could be special names when you fit a value for x into it. So when you put values of x into it, the other ways that it could be asked is you could be asked to find a formula for f dash 3. That is called the derivative of the function at 3, and it just means whenever you see x, you substitute in x, you substitute in 3. And the other one is if you are asked to find the rate of change of a function at 3, then you're doing f dash 3. Now you'll get used to all of those things because I've not really told you what the function is yet. Now further down the line you'll also get something where f dash x stands for the gradient of a tangent to a curve, and that's going to be really important but not too much for you to worry about just now. Okay, so the process of finding f dash x from fx is called differentiation. So it's what this whole unit is about. So when we differentiate fx, we get f dash x. I haven't told you what you do to get it yet, so we're going to go and we're going to look at that. So how do we find f dash x when we know fx? Now there's a simple rule and then you've got to learn it. Okay, so but I'm going to tell you the rule how to find f dash x when you know fx. Now, it can be dead easy, or sometimes it can be quite hard to find f dash x, but as long as you know your laws of indices, it can be straightforward. So that's your surds and indices, you must know that. Now, formulas have been worked out so that you can find it, and find it quite straightforwardly. So the first one you've got to learn is, so this is rule number 1, if fx is equal to c, and c just stands for a constant, it stands for a number, so it could be 5, it could be 2, it could be 6, it could be a half, it could be 0.5. So if you've just got a number there, there's no x's or x squareds, then f dash x is equal to 0. So there's a few examples. If I ask you to find f dash x and fx is 5, then f dash x is 0. If I ask you to find f dash x when fx is equal to -8, that's a constant, so it's 0. If I ask you to find f dash x when fx is 3/4, then it's equal to 0. Okay, so that's the first rule that you have got to learn. Now, the only other one you're going to learn in this lesson, and the only one that you're going to need throughout most of this chapter, is this thing here. So if we know fx is equal to a number times x to the power of something, then to find f dash x is that thing. Now that is quite hard to see what you're doing. So there's n, you multiply by n, the ax stays the same, and the only other thing that changes is the power. So instead of it being the power of n, it becomes n minus 1. Now that's mathematical symbols. They're always harder to look at and make a difference. So if we multiply by the power, then subtract 1 from the power, that gives me the derivative. So there it's multiplying by the power was originally n, so I've multiplied by it, and I've taken 1 away from the power. So that wee statement you must learn. So to find f dash x, you multiply by the power, then you subtract 1 from the power, and it can be dead easy. Okay, so first one here. If fx is x to the power of 4, then f dash x is multiply by the power, so I'll multiply by 4. So it's 4x to the power of, and take 1 away from the power, so instead of it being 4, it becomes 3, and that's all you have to do. So if fx is 3x to the power of 5, multiply by the power, so 5 times 3 is 15, and it's x to the power of, take 1 away from the 5, it's x to the power of 4. So the next one, if fx is a half x squared, multiply by the power, so a half times 2, 2 halves are 1, so it becomes 1, x to the power of, take 1 away from the power, and it's to the power of 1. So I haven't put any of those numbers in there because that should really be 1, x to the power of 1, but we don't need that. We know that that's just the same as x. Now we can move on to take the derivative if you've got things that are added together or subtracted. So if you've got a string that's added or subtracted, you can do each term individually. So we'll do the x squared, multiply by the power becomes 2, take 1 away from the power becomes 2x to the power of 1, which is 2x. Okay, so 2x to the power of 1 is the same as 2x. Then you move on to this one here, the derivative of 3x to the power of 3, multiply by the power, 3 3s are 9, x to the power of, take 1 away from the power, is x to the power of 2. So you've got 9x to the power of 2. So you can do a string. Right, next one. Doesn't need to be x's, it could be any letter. So if our function ft is equal to 4t squared minus 3t, and I've put a wee power of 1 in there, so it's 3t to the power of 1. Then to take the derivative of that, multiply by the power. So 2 times 4 is 8, so it's 8t to the power of 1. That's what I've got there, 8t to the power of 1, but you don't need that one. Now this one here, I've got minus 3t to the power of 1, multiply by the power of 1, so 1 times minus 3 is minus 3, and that's t to the power of 0, so I've got minus 3t to the power of 0. Now, do you remember what anything to the power of 0 is? Anything to the power of 0 is 1, so that's 8t minus 3 ones are 3. Now, another way of remembering is you drop down a power of x or a power of t or whatever it is, so if that was t squared, it goes to t. Now, if it's just t on its own, t to the power of 1, it just goes to the number in front. Right, next one. Okay, so we've got a longer string here, but we'll do them in each wee bit at a time. So we've got fy is equal to y to the power of 3 plus 4y squared minus 3y plus 5. So the derivative of y to the power of 3 multiplied by the power is 3y to the power of 2. Then add on 2 times 4 is 8y to the power of 1. So that was me taking 1s away from the powers, and that's those 2. Then we get to minus 3y, so that's 3y to the power of 1. So that becomes 1 times minus 3 is minus 3y to the power of 0, but y to the power of 0 is 1. So that just becomes minus 3. Now, a constant, that was rule number 1. If you take the derivative of just a number, it's 0, and I don't need to put anything in there. Now, sometimes you need to simplify first. Okay, so there's some examples there. If you're asked to take the derivative of something like x plus 4 all squared, you've got to multiply it out first. So when you multiply it out, you get x squared plus 8x plus 16. And then the derivative, f dash x, multiplied by the power, is 2x to the power of 1, which is 2x, plus 8x just becomes 8, and 16 disappears, so it becomes 2x plus 8. There's another pair of brackets. You can't do the multiplying bits, so you've got to multiply those two brackets out until it's all pluses, sums or differences. So that becomes x squared plus 3x minus 4. Derivative of x squared multiplied by the power, take 1 away from the power, is 2x to the power of 1. So that's that. The derivative of 3x, it just becomes 3. And the derivative of minus 4, it goes to 0. So there's nothing there. Okay, I'm going to do a few extra wee examples. So if you've got fx is equal to x to the power of 8 minus 3x, and you want to find f dash x. So f dash x, take each term in turn, multiply by the power, take 1 away from the power. So that'll become 8x to the power of 7. So 8x to the power of 7. Now this one here, minus 3x, that's 3x to the power of 1. So 1 times minus 3 is minus 3. Take 1 away from the power is minus 3x to the power of 0. But anything to the power of 0 is 1. So that would be 8x to the power of 7 minus 3 ones are 3. Now, you can see 3x derivative becomes 3. If you've got fx is equal to 7x, f dash x just is equal to 7. If you've got fx is equal to 10x, then that becomes f dash x is equal to 10. If you've got fx equal to a half x, then that just becomes f dash x is equal to a half. Okay, and that's because it goes to x to the power of 0, which is 1. But you don't need to go through all of this. Just learn that. You drop the x and it becomes the constant. Right, so another one, a string this time. So fx is equal to 3x to the power of 4 minus 7x to the power of 3 plus 2x plus 5. It's a bit longer one this time. Right, so f dash x. 3x to the power of 4 multiplied by the power becomes 3 fours are 12. X, take 1 away from the power, so it's 12x to the power of 3. Multiplied by the power gives me minus 7 times 3 is minus 21x to the power of, take 1 away, is 2. 2x to the power of 1, that's going to drop to the power of 0. That just becomes plus 2. And a constant disappears, it goes. So I have nothing in there. Right, another one, fx is equal to 16x squared plus 8x plus 7. So f dash x becomes multiplied by the power is 2 times 16 is 32 x to the power of 1, which is just 32x. Then I want to add on derivative of 8x, it just goes to 8. Derivative of 7 goes to 0, but I don't need to put the plus 0 in. Okay, a few more. So fx is equal to 3x to the power of 3 plus 2x to the power of 2 plus 7x's minus 1. So f dash x is equal to 3 3's are 9, x to the power of 2. So multiply by the power, take 1 away from the power. 2 times 2 is 4x to the power of 1, which just becomes 4x. And 7x, x to the power of 1, take 1 away from the power, becomes x to the power of 0. X to the power of 0 is 1, so it's just plus 7, and numbers disappear. Right, fx equal to 12 minus 2x minus x to the power of 3. So same rules, f dash x, the derivative of a number is 0, so that's 0, but I don't need to write 0. Derivative of minus 2x, that becomes minus 2. And derivative of x to the minus 3 multiplied by the power is minus 3x to the power of, take 1 away, 2. Right, last one for now. fx is equal to 20 minus 7x's minus x to the power of 4. So f dash x, the derivative of 20 is a constant, it's a number, there's no x there, so it's just 0. I don't need to write anything down. Derivative of minus 7x's, it's only x on its own, x to the power of 1, so it would go to x to the power of 0, so that just becomes minus 7, and then multiply by the power is minus 4x to the power of 3. Right, what I want you to do is, I want you to do this exercise here, and I'm going to enlarge it a wee bit so you can see the full thing. Okay, that's up to question 11 it should be. So we've just managed to squeeze that in there. Right, so I want you to write down the derivative of each of those things. Okay, so exactly what I've done. Right, so go through all of them. Now, once you've done them, I want you then to do this exercise here. Now, for this one, some harder ones here. So I just want you to do question 1, question 2, and then question 2, A, B, C, D, E, and H. And then I want you to do question 3A only. Now, that symbol there, I haven't told you that yet. That is just the same as finding f dash x. And you're not doing that one. So that one's out, and that one is out just now. Okay, now you need indices for that one. That is equal to x to the minus 1/3. It's a wee tricky one there. We'll see if anybody gets that one. Okay, and loads of indices for that one. Okay, and that one. Right, so this exercise is a wee bit more difficult. Do it, and next day I'll go through the answers to all of them, but please try them first. Now, our plan was I started a new chapter today, and I'll do the next exercise tomorrow. And I said on Friday I was going to give you a wee test. Now, Friday is an in-service day. Not an in-service day, it's a holiday. Monday's an in-service day. So what I'll do is I'll post on Friday the wee test, and I want you to do it at some point, and on Tuesday I will do the solutions to the test, and you will mark it and see how you get on. Okay, but do your differentiation questions for tomorrow.